feel the need.
The other recordings have been useful, but it's just. Yeah, this is rough.
Dude, it was solid 2 hours last time. I know. Some persistence going, some grit going on. I like that. That's good stuff. All right. Trust problems. This, I'm just going to refresh your memory, called the method of joints. Because we will venture into a new method today. After we get done confusing ourselves with this method, we'll start a new one. Yeah. That's it so far. Yeah. Yep. All right. Should start with what? What's our first step? FBD. What's our second step? Reactions. What are those? Reactions are what? Yeah, it's when we take a support out and we put a force in. That's a reaction. So there was a pin at E, correct? And there was a roller at F. So I did that. 2 at E, 1 at F. Now, how do we solve those? Yeah, so apply equations. And that's some forces in the X, some forces in the Y, and a moment, potentially, right? So I heard Nick say moment at E to solve for Fy. And that's what you want to think about it. Like if I'm doing a moment at E, I'm trying to solve for Fy. If I'm doing a moment here, I'm solving for EY. If I'm summing forces in the X, I'm solving for EX, right? All right, so let's do it. Sum a moment at E. You definitely want to just slow down and get this right, because this sets up the whole problem, right? Get this wrong, you're really in trouble. All right, what are all the forces that create moment and their rotations? Gesundheit squared.
What?
20 kilonewtons times 8. Rotation. Clockwise, negative. I did hear EY, but I heard 20 also. So we'll throw EY in there now. EY times 6. Rotation, I drew it up. So my rotation is
Wait, I thought that. We were doing the moment about E, right?
E. Fy.
So we're gonna be F.
Maybe I heard Fy. I heard something.
Okay, there we go.
Sorry.
Yeah, I was like.
Fy. Yeah, EY drops out, EX drops out,
Okay.
for sure.
That
That was a test. I was quizzing you.
Sounds like we all passed.
I think you got it, yeah. Rotation is positive. What else creates moment about E? 10 times 8 and 8 is 16, and rotation is negative. I heard all that. What about this 100? No, goes right through the point, drops out. What about this 100? Yeah.
Oh, shoot. See, I wasn't taking into consideration the rest of them.
You have to do all forces. When you're doing a moment about a point, the truss is still intact. We've not taken the thing apart. You have to do every force.
Yes, yeah, that was just, we're just focused on those. The C, E.
No. We're not even close to that stage yet. Don't do that. Do these things in order. Free body diagram first. Find the reactions second. That's nothing to do with the individual members.
Yeah, I
Nothing.
guess I misunderstood and I just took that out. Focus on that little bar.
Gotta do the whole truss first. So we need this 100 times its distance. What's its distance? Line of action is here. Distance is here. 6. Yeah, agreed. And then the rotation of this about this point, negative. All that's equal to 0. What do we get for Fy? 153. Anybody else get 153? I would have. Juan says he did. Nick says he would have. What's the whole number? 153.33 repeats, and that is kilonewtons, and it came out positive. So it does point up. Excellent. So then how much is EY? Just getting that from some of the forces in the Y, right? Like we got 200 coming down. We got 153 going up, so we need another. Yeah, what's the number? EY 46.66 repeats, kilonewtons.
Sorry, can you explain that again?
How do we get forces in the Y? Right, if we know Fy. Right, and we know 100's coming down and 100's coming down, we know we got 200 coming down and we got Fy going up, how big does Ey have to be? Because the sum of the forces has to be equal to 0. So it's 200 minus the 153 number. Yeah. Excellent. Yeah. So we got 46.66 repeat here, 153.33 repeat here. What about EX? Yeah, some forces in the X. It's got to balance out. So we have 30 going to the right, we need EX going left. In the beginning, for reactions, the whole truss is together. We don't even care that it has individual members. It's like a big solid block of who cares. To get those reactions. Now what? Yeah, method of joints says start in somewhere, pick a spot. You can pick anywhere. But I would choose the simpler ones, the ones that have 2 unknowns or less. F is a great spot. It is a T. Not a cross, but a T. Joint F. Special case. 53.33 DF EF. 2 of the things we wanted to know. These are a special case and we want to try to identify it because they're very helpful. Everyone okay with my drawing the F? Right, which way does DF have to go? Down. And what's its magnitude? Yep. And then which way does the EF go? That's a trick question.
Yeah.
Out or in, either one, because EF has to be equal to what? Remember, this stands alone, all by itself. When you look at the joint, when you look at a joint, you just look at the joint and you say, okay, some of the forces in the Y have to be equal to 0.
Oh,
Some of the forces in the X have to be equal to 0. How many forces do we have in the X?
sorry.
Which, how many? Right here.
0. Equals 0.
EF has to equal 0. It's called a zero force member. Because this joint has to be in equilibrium, so then all the sum of the forces are equal to 0. We made the y's equal to 0, set 153 to 153 and pointed them against each other. If there's only a single force in a direction, it's got to be equal to 0. So we look for these clean T's. And they're throughout our truss systems. Right? We do not want to misread them or it'll really screw us up. In other words, you want to look for zero force members, but you only want to make sure it's a T. Now, it can be, they can hide in trusses. For example, let's look at this one. Do you see a clean T anywhere? What member? Yeah, point C. There's a clean T. There's no external force on C. So what member has to be 0? CE is 0. Has to be based on the analysis of point C. Not based on the analysis of point E. You could never determine that by looking at point E. There's 4 forces at E. And they're going all different directions, right? But based on the analysis of point C, that has to be 0. So we do like to see those. They can be contagious. In other words, something can happen at the other end too. For example, point E. If I draw the free body diagram of E, zoom tight, and I leave CE out because it's a zero force member, right? I get this. And I'm going to put the axis here, X and Y. This member also becomes 0 based on this connection. Everyone see that? It's a little trickier when the force is at an angle, but when your force is at an angle, if I put my axis here, X and Y, then I kind of rotate it in my head and say, okay, I have this now. And if I sum forces in the Y, the only force I have in the Y is this component of this thing, right? That's got to be 0. If the component's 0, that's got to be 0. These are called zero force members. They're super handy to identify. You just can't misidentify them. So if you're not sure, don't do it. The equation will solve it for you. Out to be 0, okay? But they are handy and they are contagious. So for this one, this becomes 0. That makes this a clean T. That becomes 0. That makes this a clean T. That becomes 0. All of this inside under this one loading condition, they're 0. That doesn't mean we could remove them. It just means under this loading condition, those are all 0 inside there. They're just not being used. If I take a force and hang it here, then both of these get loaded immediately. And I no longer can do that shenanigans, right? So you do have to be very careful with it. But we do like to see these kind of T's. These are really nice, right? Boom, boom, that's 0 for sure. All right. Good, good. Now where do you want to go? We found these two. Yeah, let's go to joint E. Because how many are unknown at E now? Yeah, these two right here are, we know this one's 0. So we only have 2 unknowns. So I will go to joint E. And I'm gonna leave EF out because it's 0. All right, how do we figure out directions here for CE and D? Can we figure out directions? You can do the angle. I'm curious about which way these go though. Does CE go up or down? Does DE go in or out?
Down.
How do we know?
We have the 46s over there, so.
But there's 2 coming down. DE and CE could both come down. So I can't determine the direction from looking at the Y. I can determine it from looking at the X. There's only one unknown in the X,
That one
right?
goes left, so it has to
Yeah.
go up.
Yeah, so you have to pick out which direction, like this has Y and this has Y, so don't look at Y. There's 2 unknown. Look at X, because this does not have X, right? This has X, and it must oppose this, so this goes this way, which means DE goes like that. Has to, absolutely has to. And if DE goes up and 46 is going up, then CE comes down. Has to. So that one we can pretty 100% sure those directions are correct. Now we definitely need an angle. So I'd probably use the 8 and the 6 to get theta here, which is theta here. Inverse tangent, 8 over 6. (53.13), our good old same old angle we always have. (0, 1). And how do we solve this? What do we do first?
I feel like the cosine to find DEX.
X's.
Oh,
X's, exactly. We want to do sum the forces in the X. Why? Why sum forces in the X? Why not sum forces in the Y? Summing forces in the X. We deal with one unknown, that one, right? If we sum forces in the Y, we have 2 unknowns. Don't want to go there. You want to pick out the direction that has a single unknown. This X component has to be equal to 30. Yep. So that means we can get DE. So just looking at DE, I know this component is 30. I know this angle is 53.13. I should be able to get DE. Cosine 53.13 equals 30 over DE. Once you have that joint, then that's what we need to look at. You don't need to look back at the truss, just focus on the joint. And solve it. Looks like it's gonna be 30 divided by the cosine. 50. DE equals 50 kilonewtons. Compression or tension? Tension. Pointing away. And now how do I get CE? Some forces in the Y. So if I sum forces in the Y, gonna have 46.66 going up. Gonna have CE coming down. Then I'm gonna have that component going up right here. So I could find that component, or you could just write the component in terms of DE, however you want to do it, because we know DE is 50 kilonewtons. I'd probably just find this component. Sine 30 equals, and I'm just working with this triangle. DEY over, whoops, 50. So DEY, that Y component, it's gonna be sine 30 times 50.
Shouldn't you be,
What?
shouldn't you be using theta?
Oh, that's not, it's not 30, is it? Thanks. Spacing out 53. 130. What was I getting? 30? Oh, maybe that. 53.1. Sine 50 times 40. This. So then that's plus 40. It's gonna be equal to 0. CE equals 86.66.
Five 53 times 50.
Yep.
Right, like nine.
I get 39.999946. So it's gonna write 39.999946, and I thought I would just write it. Okay,
Makes sense.
compression or tension on CE. We get that from this little diagram. It's pointing in, it's in compression. So we have DE at 50 tension. And 86.66 pressure. 0 here. And 153 here. Pressure. And if we were doing the whole truss, we just keep going. Such fun. Just keep going. But I only said the bottom ones. Question?
Now, I didn't get the last part. The last, when you were making the sums of why?
This one.
Yeah. Plus 46.
Yeah, so that's this one. So summing the forces and the y's, this one, 46. It's this coming down, CE. And then it's this component of DE, which we found right here, DEY.
Okay.
All right, let's go to the next one. That one, yeah? We wanted those three to the right. EF, EI, IF. So here's the deal, a little bit of a shortcut. If you know you're going here and you're solving connections over here, right? You really don't need these. Agreed? Yeah. So if you're given a problem like this, like on a quiz or something, like, okay, I need FY, and then I can just go to work with the method of joints. I don't really need AY and AX. That makes sense? Yeah. So let's just do right away. Let's go some moment at A to get FY. And then we'll just start right in on, point F. Or point E or point I, whatever you decide. So what are the moments about A? We have 10K times this one times 20. Rotation negative. 6K times what? Careful. 25. Rotation negative. 8K times 35. Negative. And FY times positive. Y equals. Well, this adds up. I messed that up. $15.75. Comes out positive, it's definitely going up. Boom, we start in at connection F. We do not want to start at E, there's 3 unknowns. We don't want to start at I, there's 4 unknowns. We definitely have to start at F. which way does EF have to point? EF has to have down effect. IF can't do down effect, right? It's all in the X. So this has to have down effect, which means that little component's got to come down. Actually, it's equal to 15.75. That means EF comes down. If EF comes down, that means EF is also going to the right. That means IF has to go left. So think through those directions if you can. Get those right. And then think through which one is all by itself, and it's that Y component all by itself. That's got to be 15.75. Therefore, we can find EF. Again, I'll pull EF out. I'll put in its down component of 15.75. Its X component, which is unknown, but we do know theta is 60.945 degrees. Just flipping right triangle after right triangle after right triangle, which is good. That's all good.
It's EFX. The same as IF,
Has to be.
just the
They're
other.
the only two, yep, other direction, correct. Yep, this and this have to be equal. So they're the only two forces in the X. So yeah, if you just solve for this, that's equal to IF. So also remember, when you have only three forces, you can do what with it? What can we do with this? Build a triangle and just solve the triangle directly. So I can go there, there, and there. Right, where this is EF, this is IF, and this is 15.75. So if you have a 3/4 system, it's gotta close, it's gotta come back to the beginning because it's in equilibrium. You have to dig out the angle and get it in the right spot. So again, the way I do that is EF to horizontal is my theta. So I go find EF and I find horizontal and I say that's theta. So that's how I do it. Theta was this, we solved for that. So if I solved it this way, then I can just run the trig to get IF directly, which is gonna be maybe tangent. If I don't want to use this and I want to use this, tangent of 60.945 equals opposite 15.7. I'm getting too close. It's bothering me. Okay, so that's kind of the alternative method, right? Is if you have a 3/4 connection, build a triangle, solve it. Just get your angle in the right spot. If you don't want to do that method, that's fine. Then just think about components, right? Some forces in the X, some forces in the Y. Y, X. So either method works for solving that joint. So that gives us E, F, and IF. IF 875. And 1802. Compression and 8. Is in tension. Now what? Yeah, got to go to E. There's too many unknowns at I. There's 1, 2, 3 at I. At E, there's 2 unknowns. So up to E we go. Serve some space. (1802) is in compression, so it points in. Then I have IE. And I have DE. Right? Yeah. Good times. Like a lot of things going on right there. What's our value coming down? 8K. Can we determine any directions here? For IE or DE? This one and this one? How many unknowns do we have in the X? How many? Does this have X effect?
Oh, yeah.
Yeah, it's all in the X. What about this?
So two.
There's 2 in the X. Right? How many unknown on the Y? Just 1, just IE. This doesn't have any in the Y.
I,
So it's, well, it depends on if this component of the 18. Right? Was that component bigger than 8?
was 8%.
Yeah, so this is EF, right? Correct?
Mhm.
Yeah, so EF was right here, and here's the Y component to EF. Right? Yeah, 15.75. So the Y component of this. Was 15.75. So we got 8 down, we got 15.75 up. Which way does IE have to go? Down. Gotta have down effect. I even know how big that is, right? If I just sum forces in the Y. I got 8 coming down, I got 15.75 going up. I need another so much coming down. The difference between those two. So once you know like components of a force, you can use those. Travel them over here to help you. So this would be some forces in the Y. -8 coming down. Right? We're just focused on this joint now. We have 15.75 going up, that's rounded. But we just pulled that from over here. But we don't know IE. But we know that that is IEY. And I can just put that in, IEY. And that has to go up, down, sorry, minus, down, 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 up. The Y component. All that's equal to 0. So that Y component of IE is 7.75.
Does that mean X component of the F is equal to DE? So it's the same thing as.
Well, you have 3 of them in the X, right? You have this, the X component of this, and the X component of this. All 3. So you have to, when you do that one, you got to consider all. But I'm just gonna finish with finding IE now, because I have IEY. I have the Y component. I need an angle, so I need to know what that angle is. And if we look back, we found our theta by doing 9/5. This one would be the same, right? 9/5. So this angle and this angle are the same. So we can use our theta of 60,945 right here. Theta. I usually just try to do that once I find one angle, if I can use it all the way through. Complicated things. So then I can just keep referring to it as theta, knowing that's 60.945. So kind of the long form of it would be pulling out IE, putting in IEY that we just found, 7.75, putting in theta, and then calculating this. And it looks like sine is going to work quite good, right? Opposite over hypotenuse. Sine 60.945 equals opposite over hypotenuse IE, which is what we want. Finally. .8. 7 pips. And it's pointing away from the point, so it is in tension. .87. What do you think? Good time, huh?
There's like software that does this, right?
What?
There's like software that does this in the real world.
There is some software, yeah. The garbage in, garbage out philosophy works really well with software. So easily mucked up.
Project, you know.
I don't know, it's a little different when you're getting paid for it. Feels better, feels better. Take your time, work your way through it. Not that I could ever figure out. If you can figure it out, then I think that's brilliant.
Cheating.
All right, I'm gonna pause the recording. So, method of sections. Typically used on longer trusses, like to do the method of joints on this, you know, it's gonna take a long time. You're gonna go point by point, and sometimes we want to know very specific things. For example, under a loading condition, maybe during inspection, something was found on member HD, right? Here. We need a method to go straight to HD. Like method of joints would say, you can't go here, you can't go here, you can't go here. You got to start here and then work your way towards it, right? Method of section says, you don't have to do that. You do need to solve for a reaction. You got to have either this side or this side, because what you're going to do is you're going to cut the truss. And typically you're going to cut through what you want to learn. So the book's going to say like find member CD, HD, and HI. CD, HD, HI, right? That would be the cut. Okay, the key is when you cut through the truss, you can only cut through 3 members. You can't cut through 4 because we only have 3 equations. Some forces in the X, some forces in the Y, and some of moments. So when you cut a truss, you can cut through 3 or less. And you can do the analysis on either the left side of your cut or the right side. Either one will give you the solution. Okay, so we solved for this reaction. I'm going to use the right side. Because we did not solve for this. If I use the left side, these would be unknowns and that wouldn't be good, right? So you need to use the side where you have found reactions, and you find the reactions before you cut the truss. So step 1 is going to still be free body diagram. Step 2 is going to be find the reactions. Step 3 would be cut the truss. 3 members or less. Okay. So, and you can't just cut through part of it, like just through CD. You got to go through the whole thing. Okay. Then you look at one side or the other. We're going to look at this side. So when you do that, the other side just disappears. It's gone. Okay. And everything you cut through becomes a member. And-
All those are already numbered?
Huh?
All those already.
Yeah, but they get vectors now. That's what I should have said, is they become vectors or unknown member forces. Okay. And we just assume them all in tension because it's normally too complicated to even try and figure out which ones are compression and which ones are tension. So sometimes you redraw the truss. Like that's probably what I'll do just for educational purposes is I'll redraw the section that I'm going to use. It's this section, right? It's this. And all of this is still connected when I do it. So I've cut through it, and now I put in, for every member that I cut, I put in a force. You assume them all in tension, and you just label them like you did before. CD, DH, HI. Put in all of the external forces that act on your half. These were K, right? Yeah. And then, of course, any distances, like we know this is 9. We know this whole thing is 10. This whole thing is 10. This is 9, right? Kind of same as we did before.
Wouldn't at point B, there be a 6?
Yep. Thank you. Don't let me miss one. Good. Everyone see what I've done? Cut it. I'm going to redraw the truss. Everything that I cut, I put as unknown forces along the line of action. That gives me, I'm just going to kind of separate this. Got it a little too close. That gives me a new free body diagram of a structure. And I'm going to treat this structure as if it was just solid. So I can't, in the method of sections, you can't determine like this member or this member or this member, because none of this is taken apart. You can find these 3. The ones you cut is what you can find. Okay. So this is point E, this is point D.
What we're looking for is HD.
Yeah, so that was how I positioned the problem was we're looking for HD. We're looking for this thing right there. And our good old theta is, I think, right here. Yep. So this sets up a non-concurrent problem. where method of joints is all concurrent. They're all coming from one point, right? So this means we can do moments, we can do forces in the X, and we can do forces in the Y. That's our equations. Okay. Then you solve it. So that, again, no new skill set, but kind of a complicated non-concurrent system. A lot of things going on here. Anybody see a quick way to go after DH? Because DH is our target. So that's the other thing you want to think about is when you're doing these things, what are you looking for? Like if DH is what we want, how could we go and get it in the least amount of steps? Yeah. Excellent. DH has a Y component, right? So if I did some forces in the Y, what are all the forces in the Y?
6.
Minus 6. DHY. And which way do I have it going? Down. What else? Forces in the Y. The 8. Yep, 15.75. Is that all of them? 1, 2, 3, 4. 1, 2, 3, 4. Set it equal to 0. DHY equals. So negative and negative move to the other side, become positive. This is positive, becomes negative. See what we get. That's what I get. Anybody else get that? I got negative 1.75. What's that mean? What does this mean? Means the direction we chose is incorrect. DHY does not point down. How do I get what?
DHY is negative. Yeah, so
Oh, wait.
Is that because we switched all the signs? When we did the math?
Well, you.
Oh, this is switching over. Oh, so that's positive. Yeah, darn. I was hoping it would come up negative. Sorry. DHY moves to the other side, so this stays negative, that stays negative, that's positive, it comes out positive.
Wait, so we don't.
Nope. Because it comes out positive. I mucked it up. But you didn't. I'm sure you got a positive number, right? So look at
How do I know not to switch?
DHY is negative. What do we do with this?
Put it on your side.
Yeah, so then all this stays here.
Oh.
Yeah, so this becomes negative.
Yeah.
This becomes positive. Yeah. Yep. Nice job. So it does point away. DHY is going to be in tension. How do we find DH? We have DHY. So that's the other thing is be very careful. This is not your answer. This is the Y component of DH. Right? Right. There's DH. Here's DHY at 1.75. Here's DHX. And there's DH. This is our theta. What was theta? 60.945. Right, that was the inverse tangent of 9/5. So I could use sine. Theta equals 1.75 over DH. DH equals. But your number? That's what I got.
Oh, you're still using the same thing.
Yeah. And how did we get theta? The theta was inverse tangent 9/5. That's how we got there. Gesundheit. You're allergic to the method of sections. That's so weird. So weird. And compression or tension. Tension points away from the point. So that rule still applies. If it points away, it's tension. Tension, tension. We don't know those because we didn't solve them yet. We just know DH. That's all we wanted though. So method of section, cut it, apply the equations, find out what you need to find out. You're gonna do all three members, not just one of the members that you cut through. So there are other strategies you should be aware of. For example, if I wanted CD, right, this one here, I would project this to here, project this to here, and I would do a moment right there. Why am I doing that? What drops out if I do a moment right here? This drops out and this drops out. Correct? Yeah, that's why I did it. I dropped two of my own knowns out. I can do 16 times 5. I can do 8 times 15. I can do 15 times 20. I can do CD times 9. The moment's pretty straightforward, and the only thing unknown is the CD. So you can project to points to do moments that is kind of off of your structure, right? You can do moments anywhere. I chose to project this to this, use this point to find that one. You'll do it in your homework. I'm helping you. Now, what if I wanted HI? Where could I do a moment to get HI?
D.
D for sure. What drops out there? Well, all those drop out. And I end up with HI times 9, 8 times 10, 15 times 15. So moments are very handy in the method of sections. Project those vectors, pick a spot that drops out two unknowns, and you'll find the third one relatively easy. Okay. Good times. All right, let's look at the whole that you're gonna do. Oh, we can look at the storms, but we'll do that later. 10 and 11, chapter 5. Both of those are method of sections. 10 is here. Boxy truss thing. Right, and it says you're gonna find BC, CH, and CG. Right? BC, CH, and CG. They're giving you 3 that you cannot cut through. You can't cut through those 3 and just cut through 3, no matter how you do it. Right? If I try to cut through these 3, I gotta come out somehow. That would be like 1, 2, 3, 4, 5. That doesn't work. I can't go like this because you don't cut the truss in half. You got to cut it in half. So they're giving you 3 that don't line up, right? Cut through here and find the 2. Then you're going to have 2 different cuts. So cut through there, choose your side, find the 2 that you need. Okay. Put it back together. and then cut again, maybe through here to find that one. And you'll have already known that one because you'll have solved it in your first cut, right? So it just takes two different cuts, and you do your cuts one at a time. Like, if I wanted to know this member, I might cut here, and then if I wanted to know this member, I'd cut again over there, right? Put this side back together, cut over here. So it takes two cuts on this problem.
And when we do the second cut for HG,
What?
we're like always cutting directly from the middle, right?
So
So,
first cut here, work with one side or the other, solve it.
no, but what I mean is like, okay, so we found the value of,
These two, actually, you probably find all
we
three.
found the value of HG and then we're doing our second cut to find CG, right?
Yep. So now you're gonna put it back together,
No, I understand that.
okay? And now you're gonna cut again. Yep.
So we just use the value of HG. and
Absolutely, that you found,
But What I'm
absolutely.
saying is like, it's still just, that value is still just half of the like actual number, right? Does that make sense?
It's the force in the member.
Okay, it's the total. force.
Yeah, it's the total force, for sure. Yep. And if you, like, if you cut here and then you find HG at 40, right? I don't know what it is, but we'll say it's 40. Pointing away, right? So it's in tension. So in the second cut, when you cut here, if you use this side again, it's the same, it's 40, right, in tension. If you use this side, it would become 40 in tension. Right, always pointing away. So it does switch if you switch sides. The direction switches. All right, so that's that one. Good luck with it. And then let's see what they do to you in 11. And of course, I'm here another 45 minutes if you want to start on them. BC, where's BC? BC is right there. CI and IJ. Can you cut through those? Yeah, so they give you three good ones there, where your cut can go straight through them and go right after it. Solve for the reactions first, section it, choose a side. I would choose the simple side where there's less going on, this little side over here. And up here, doesn't really matter, it's like busy on both sides, so this, notice, is a roller. It looks like a pin, but under close inspection, I don't know why they're getting cute like that, but it's a roller. It's got little wheels under it. Nice. I'll not just put a round circle. I don't know. But yeah, that's a. All right. Quiz is up and available. You have all day to do it. Please don't work together. I want to know what you know. But don't forget to do it. I mean, you could do it now and just get it done. It's got to be submitted. And yeah, have a good weekend.